0.3.2. Now let us move on to application. Right, question 9, whereby we are given this window frame and we need to answer these respective questions in respect to this window. Now, since a window frame with dimension y by h is illustrated below. Now, the frame consists of 6 smaller frames. Now, 9.1 says if 12 meters of material is used to make the entire frame. Now, with regards to application questions, there are 3 important formulas you need to know. You need to know the formula for your area with respect to different shapes, as well as the formula for your volume, and lastly, the formula for your perimeter. Right now, in this case, you can see we have cubes as well as rectangles. So the area formula that is applicable here is length times breadth. Right now, what about the formula for your volume? So the formula for your volume is length times breadth times height. So it's length times breadth multiplied by height. Now, with regards to the perimeter is the sum of all sides, right? Basically, when you add all sides of this window frame, right, the value that you would get as a result of that, it would be your perimeter. Now, they say if 12 meter of material is used to make the entire frame, meaning that the perimeter of this entire frame is 12 meters. Right? Now, based on that information, we need to show that your y can be written as 1 over 4 brackets 12 minus 3 multiplied by h close bracket. Right? Now, let's go about doing that. Now, I know that how many vertical poles do I have? Now, this is the first pole. This is 1, 2, 3. Now, these are the poles in which they are equals to h, right? So I have 3 poles which are equals to h. So I have 3h. Now, plus how many poles in which they are horizontal? I have this is the first horizontal pole, 2, 3, 4. So I have 4 horizontal poles. So, and these, remember your horizontal length is y. So plus 4y. Now they say all this is equals to 12 meters. Right. Now we need to show that y can be written in this form. Now, basically, let's solve for y. So the first step, I'm going to take this 3 to the other side so that I'm left with 4y. My 4y is equals to 12 minus 3h. All right. And now to remove this 4, right, I need to divide both sides by 4. Right. So if I divide both sides by 4, so dividing both sides by 4 is the same thing as multiplying both sides by 1 over 4. Right. So basically, I'll be left with y. This is equals to 1 over 4 multiplied by 12 minus 3h. All right. Now we have proved that y can be written in this form. Now, remember, with regards to application questions, what they require you to calculate here, you would need to make use of it on the preceding question, right? Now, let us write our y to be in terms of h in this case. Now, they say I'm going to show that the area of the entire window can be written as a is equals to 3h minus 3 over 4 multiplied by h squared. Now, remember the formula for your area in this case is going to be length times breadth, right? Let me first step down by writing it. It's length times breadth. Now, in this case, this is the same as y multiplied by h, right? But remember, I have written my y to be in terms of h, right? So basically, this is the same as 1 over 4. So this is the same as 1 over 4. So this is the same as 1 over 4 multiplied by 12 minus 3h, which is for this y, multiplied by h, right? Now, let me simplify this, right? First, let me start by distributing this 1 over 4 into this bracket. So I'm going to say 1 over 4 multiplied by 12, as well as 1 over 4 multiplied by minus 3h, right? So this is going to be equals to, so still brackets, 3. So this is going to be equals to 3, right? And minus 3 over 4h. Remember, all this is multiplied by h. Now, distributing this h into this bracket, right, I would have 3h minus 3 over 4h squared. Now, we have proven that our area can be written in this form. Now, 9.3 says find dA over dH, basically the first derivative, and hence the dimension h and y of the frame, so that the area of the window is a maximum. Now, whenever you have a question relating to maximum and minimum, just know you need to find the first derivative. Now, in this case, because we are talking about the area, we need to find the first derivative of this area. And after we have found the first derivative of this area, we need to equate it to 0. Right? Because remember, your maximum point, going back to your cubic function, right? Remember your maximum point, or sometimes you get it to, right? In order to find your local maxima and your local minima, you need to take your first derivative and equate it to 0. Now, in this case, we're going to find the first derivative of this, and afterwards, we're going to equate it to 0. right, to solve this question. Now let us go about doing that. Now, the first derivative of our area, right, so deriving this 3h is going to be equals to 3 minus, so 3 over 4 multiplied by 2, it's going to be 3 over 2. So this is 3 over 2h. Now, remember I said we need to take this first derivative and equate it to 0. Now we have equated this to 0, then we've taken this 3 over 2h multiplied by h to the other side, right? From there, we need to eliminate this 3 over 2. Basically, we're going to divide both sides by 3 over 2 so that these two can cancel out one another, and your h should be equals to 2. Now remember, we solve for our dimensions if our area is a maximum. Now our dimension consists of both our h and our y. Now we have solved for our h. We say our h is equals to 2 if our area is a maximum. What about our y? Right? So remember, this is our formula whereby we've written our y in terms of h. So we can just simply substitute this 2 here, and then we would find our dimension y at a maximum. So basically, this is 1 over 4 multiplied by 12 minus 3 is 3. You're going to multiply by 2, right? And then punching this into your calculator, your y should be equals to 3 over 2. Now, basically, your dimensions, right? So these are your dimensions if your area is at the maximum. Your y is going to be equals to 3 over 2. Your h is going to be equals to 2, right? Now, this is all for this practical. If ever you have any questions, always feel free to reach out.